I work for Red Hat as a software engineer, and I focus on Windows guests. And this talk is about nesting Hyper-V on KVM, which has been kind of a hobby project of mine for the last year or so. And what I'm going to cover is the what, the why, and the how. So very briefly, because I'm sure most of you know what Hyper-V is, what nested virtualization is, why we care, specifically for Hyper-V on KVM, and lastly, how it works. And this is actually a spoiler because now you know that it works. And there's going to be a demo at the end. So Hyper-V is Microsoft's hypervisor. You can get it with Windows. You also get it on Azure, on Microsoft's public cloud. The reason why I included this screenshot is to kind of show you how you enable it, and I'll get shortly to why I'm showing you this. So there's this thing called server manager, where you can add these roles to your Windows Server installation. And there's things like DNS, DHCP, fax, whatever services, and one of them is Hyper-V. So you just check this checkbox, you reboot, and you have Hyper-V, you have a hypervisor. It looks like you're just adding something to your operating system, right? For those of you familiar with KVM, which is probably most of you, it looks like the equivalent of maybe loading the KVM module and the KVM Intel or KVM AMD module. However, Hyper-V is a true, is really like a type 1 hypervisor. So what really happens is you get this whole new layer at the bottom sitting on top of hardware, right? So these things, the Hyper-V calls partitions. You can think of them as VMs. One of them will be the root partition, the Windows that you interact with, the management OS. So in this sense, Hyper-V is much, much closer to Xen than to KVM. And as a consequence, just by enabling the Hyper-V role, you will get nested virtualization. Unlike Linux, where just loading the KVM module doesn't really start any VM, right? You have to do it explicitly. So that covers Hyper-V. Nested virtualization, there was just a talk before this one about measuring the performance of nested virtualization. I'm pretty sure most of you wouldn't find this picture surprising, maybe except for this L-shaped piece, which again comes back to the fact that once you enable Hyper-V, you also get Windows pretty much sitting at L2 at that point. So even if you don't start any nested VMs explicitly, you already have an L2, which will be Windows itself. And so this is the setup that we're interested in. We have Linux with KVM as the L0 hypervisor, Hyper-V being the L1 guest and L1 hypervisor, and Windows in L2. So why you want to do this? There's this, like I would say, the toy use of nested virtualization captured in the first bullet. Having worked on virtualization for under like 2 years now only, I feel kind of, I'm not qualified to generalize and tell you what all the possible uses are, but I'll give you examples like from like my experience for this use of nested virt. One of them was a person who wanted to demo a product called CloudForms, whose purpose is to manage all kinds of hypervisors, all kinds of clouds and whatnot. And this person wanted to demo KVM-based hypervisors as well as Hyper-V on his laptop. So he wanted to run Hyper-V on his laptop. Cool, right? Why not? Another one, so this one would be kind of a training or demo. For development, I recently started looking at supporting V2V migration from Hyper-V to KVM. And again, for this use case, it's kind of nice to have it all on one host. You don't need additional hardware for the Hyper-V host. And there's a new use case coming with Windows Server 2016 and Windows 10, which is called virtualization-based security. So what this basically is virtualization providing a sandboxing the operating system so that it cannot hurt itself. It's protected from itself and or from malware. There will be one more slide on this. It seems to be getting good reviews from security researchers so far. And so why Hyper-V on KVM, except for why not? Hyper-V on Hyper-V already works. And actually, even like today on Azure, you can get a VM which does support nested virtualization. And we do expect demand for Hyper-V on KVM as well, and probably driven mostly by VBS, by security. And so what is virtualization-based security? What Microsoft did was basically they defined these what they call VTL, virtual trust level, something that's orthogonal to CPL, to your rings, and it's a way of isolating or sandboxing or removing permissions from the code running on the machine. Because the observation is that the kernel is huge. On Windows, you have third-party drivers often of questionable quality, and once you are in the kernel, you basically own the machine, right? You can do whatever you want. You can run arbitrary code. You're basically doomed. So with VBS, the root partition, the management OS, runs in this VTL 0, where it doesn't have access to it doesn't have access to all memory, basically, to all physical memory. And how it's implemented using second-level address translation, so EPT on Intel or NPT on AMD. You still need to access this all the memory from somewhere, and that's code running in VTL1. And it's a much smaller amount of code. There's no third-party code, only Microsoft code, and it's like much easier to audit and to kind of provide some security guarantees. So they market this under a bunch of different names. There's a bunch of different names: virtualization-based security, hypervisor, code integrity. I will use the terms device guard, which is something that uses second-level address translation to enforce this W exclusive or X, which means that it never makes a writable page executable at the same time. So pages are either executable or writable. And the other marketing name they have is Credential Guard, which completely hides pieces of physical memory by enforcing no R. So memory cannot be read for code running in VTL0. And of course, this is for memory read and written by the CPU. You can have memory can be accessed by DMA, by the PCI bus, and so on. So for this to be 100% bulletproof, you also need IOMMU, and they also require you. So IOMMU is still, I think, optional. What they require you to use secure boot, though, because if you cannot guarantee that what you have booted is secure and authentic, then all of this can be compromised, right? So I decided to try it once it was working. And so I'll give you a few seconds to read this code. The C3 is the opcode for the return instruction on x86. And so I ran this code in the kernel on Windows. So what do you think happened? So I have heard page fault. Yeah, it started as a page fault and probably escalated to be this, right? Because you just try to execute your stack, and that's not allowed for good reasons. So it says attempted execute of no execute memory. So this is without device guard. This is just your plain Windows. So what I did next, I did something nasty, and I wonder why it's not yellow. It's supposed to be yellow. So this is the new statement. And what this function does is it finds the PTE corresponding to this address, and it clears the XD bit. XD meaning execute disable. So I'm malware, right? And I decided I really want to execute the stack, so I'll manually clear the execute disable bit. So then on plain Windows, without device guard, this worked. It did nothing because it calls the return instruction, returns, nothing happened. But once I enabled device guard, I got a blue screen again. It's interesting because it's a different one. It says system service exception, just kind of indication that something else is happening under the covers. And this something else is that I really was able to clear the bit from the page tables, but the execute access was blocked at the EPT level, at the second level address translation level by the hypervisor. And that's how the hypervisor caught it, and it triggered blue screen again. Okay, so how does it work? It's nested virtualization, so should be pretty much the same as KVM on KVM, right? In theory, yes. In practice, the problem is that the virtualization extensions, which when operating in nested mode, are emulated by the L0 hypervisor. It's like hundreds of pages of the CPU manual, right? So it's very easy to miss something, and that's exactly what was happening in most of the problems that I have found. So I have a few categories of issues. I think I found only one Hyper-V bug so far, which has to do with the APIC and using the version of the local APIC to, and then based on the version of the local APIC, expecting a certain register in the IO APIC which QEMU, KVM QEMU happens to not implement. So this is still, I'm still tracking it as a Hyper-V bug and trying to find a way how to report it to Microsoft. But everything else were bugs in KVM. Also, a few of these were missing features, like something that was very easy to discover because I would boot Hyper-V and it would leave a message in the event log saying, I cannot run on this host because you are not providing this and this functionality. One of these was the descriptor table exits, which KVM doesn't use, but Hyper-V does. So the only thing that was that Paolo did, thank you, Paolo, was to add like a minimal support that reflects these VM exits to the L1 hypervisor. And then there were many bugs. Most of them reproduced as the guest, or like Hyper-V not booting, hanging. So very few of these were of the nature where you would just, it would be easy to tell what was going on. So there's a lot of detective work because Windows is closed source. So it's hard to debug. A lot of reverse engineering. And it's about 20 KVM patches, a little bit of QEMU work, and recently there was an OVMF patch. Okay, demo. So this is Windows 10. Running with device guard enabled. Microsoft provides this tool which you can use to enable device guard, enable disable, check if the machine is capable of running device guard. And there's also a this dash ready switch which tells you if device guard is enabled. So this is going to be a proof that it is enabled once it finishes running. Also, okay, it's all green, which means that it's enabled and it's running. Another way to show you that is to run a tool called msinfo32. And there we go, device guard, virtualization-based security is running. We have secure boot, we have virtualization support, and so on. Another proof, if this wasn't enough, is to run KVM stat. This is the only VM running on this host. And notice that we are getting nested VM exits. And also notice that given that this is an idle guest, the number of VM exits and nested VM exits is pretty high. So future work, definitely performance. Some of the performance improvements that will be done for the general nested case will apply to Hyper-V on KVM as well. Some of them may be Hyper-V specific because as of, I think, the version 5 of the Hyper-V top-level functional specification, Microsoft started documenting some of nested specific power virtualization features. I actually tried to implement at least the enlightened VMCS, but was hoping to have it ready by the talk and to show you numbers, but it turns out that the spec shows you a few data structures of what the nested like Hyper-V hypervisor expects, but they then fail to fully specify some of the data types in those data structures, and so there was some reverse engineering still. So this is definitely for the future. The enlightened VMCS is something like shadow VMCS, but it's going to work on all CPUs. It doesn't require any hardware support, and I think it's going to should be even faster than shadow VMCS, because what they do is they instead of having the nested hypervisor execute VM read and VM write, it just reads and writes from its memory, from the guest memory. And what I want from you guys is please test Hyper-V on KVM when you make changes that touch nested virtualization code in KVM. You can get Windows Server 2016 evaluation version for free. It can be downloaded, works for a few months, I think. And when you run it, just use your usual Hyper-V enlightenments, plus, of course, VMX on Intel and SVM on AMD, so that you enable the virtualization extensions in the guest. And if you run an older version of Hyper-V, like 2012 R2, you also need to specify minus hypervisor, because that version didn't officially support running nested, so it will fail when you run it, and it detects that it's being run in a virtual machine. And just a few debugging tips. In the beginning, I used the GDB stub a lot. The problem with the GDB stub and debugging Windows is that Windows uses ASLR in the kernel. So addresses change. The modules, even the hypervisor, is loaded to a different address every time you run the guest. So what I did was I just had a pattern and a script, GDB script, to search for a known pattern in the guest memory to find the hypervisor, and then set breakpoints and so on. What I discovered recently is that Windows actually supports debugging of the hypervisor over serial or 1394 connection, very similar to how you debug the root partition on Windows. So in summary, Hyper-V on KVM works. It is slow. It is used under the covers by a couple of security features in the latest Windows versions. And to keep in mind that just enabling the Hyper-V role starts L2 automatically. Okay, so my email address, I keep a blog which is kind of focused on Windows guests, and it has a few posts about this. I don't think I have anything about device guard yet, but I'll add it shortly. And this is a pretty good presentation from Alex Ionescu from 2 years ago, if you're interested in learning more about how virtualization-based security works. And I would like to thank KVM maintainers for their help and for their patience with me, and Red Hat QE team for finding a lot of bugs. And now it's your turn to ask questions.
Just a comment on KVM on Hyper-V. You had some, kind of a maybe it work, but actually we are working on that, and then it runs well.
It runs well.
Yes, and then performance is also good. And especially if you compare Hyper-V on Hyper-V versus KVM on Hyper-V, Hyper-V on Hyper-V does better job, especially, for example, random I/O, that kind of area. So this is opposite, but if we add the enlightenment to KVM, for example, then KVM can actually run faster on Hyper-V as a guess. So yeah,
Yeah, definitely.
that's also I think an interesting area to look at.
Yeah, that's something I also want to look at. So when I implement or at least research the enlightened VMCS, I would like to implement both the part that offers enlightened VMCS on KVM, which would enable Hyper-V running on it, and the other way also.
Yes. Also, they are adding more enlightenment, especially memory management. For example, guests can tell this part of memory is hot or warm or cold, that kind of thing. So that may be also interesting.
Okay, thank you.
When you were doing the analysis of what you need for Hyper-V, one of the things you mentioned was IMMU. How do they deal with RMRRs, the exclusion ranges that are used for USB devices to emulate such? Do they actually say, no, you can't run on a hardware with this, or do they allow it to work?
I only heard I could hardly hear you, but you are asking about IOMMU. So I know very little about that. So this is very early stages. So what I showed you, the demo I showed you, is actually using a few patches in the kernel that are not in, I don't believe they are in mainline yet, plus one OVMF edge. So this is very bleeding edge. And so I just got to the point where it runs. I haven't had time to explore, but I'm definitely going to explore more the additional requirements that device guard has, like IOMMU, and a few more, because the tool that I showed you that was all green, when you run it in the mode where you ask it, is this machine capable, it lists a few things that we do not support now. There's TPM also, TPM is another example. Okay, this is it then. Thank you.